It began with a flicker, a faint anomaly in the vast data streams flowing from observatories worldwide. On June 25, 2025, the Asteroid Terrestrial Impact Last Alert System, ATLAS, in Hawaii detected an object moving at an unprecedented speed of 152,000 miles per hour. Unlike any known asteroid or comet, this object, later designated 32 Atlas, followed a trajectory that defied the gravitational constraints of our solar system. Telescopes from South Africa to Chile confirmed the sighting, and NASA soon validated the discovery. This was no ordinary celestial body. Its origin lay not within the Oort cloud or near Neptune, but in the vast, uncharted expanse of interstellar space, possibly the galactic core. For decades, humanity had gazed into the cosmos, assuming its silence and indifference. The discovery of 32 Atlas shattered that notion. This object, traveling for tens of thousands of years through the void, had entered our solar system with a precision that chilled astronomers. Its path was too perfect, its speed too relentless, and its reflective properties too anomalous to dismiss as mere cosmic debris. As the James Webb Space Telescope, JWST, turned its unparalleled gaze toward this intruder, the data it returned hinted at something humanity might not be prepared to confront. What if this wasn't just a visitor, but something observing us in return? The initial detection of 32 Atlas sparked a frenzy in the astronomical community. Atlas, designed to identify near-Earth objects that could pose a threat, had never encountered anything like this. The object's velocity far exceeded that of typical asteroids or comets, and its trajectory suggested an origin beyond our solar system. Simulations tracing its path backward revealed no connection to any known celestial body within our galactic neighborhood. Instead, its trajectory pointed to the distant reaches of interstellar space, a region so remote that its origins could only be speculated. The object's properties were equally perplexing. Its brightness suggested a massive size, yet measurements indicated it was relatively small, perhaps no larger than a football field. This discrepancy implied a surface far more reflective than typical rock or ice, possibly metallic or engineered. Unlike comets, which often display a glowing tail due to outgassing, 32 Atlas showed no such features. Its lack of emissions, combined with its high reflectivity, raised questions about its composition. Was it a natural object with unprecedented properties, or something else entirely? Astronomers worldwide scrambled to secure observation time on the JWST, the most advanced space observatory ever built. Launched in 2021, JWST was designed to peer into the deepest reaches of the universe, capturing light from the earliest galaxies. Now, its infrared instruments were trained on an object much closer to home, one that challenged every assumption about the cosmos. Early data from JWST revealed a thermal signature that was stable and patterned, unlike the chaotic emissions of natural celestial bodies. The object's spin exhibited a symmetry rarely seen in asteroids, and faint electromagnetic fluctuations hinted at internal complexity, perhaps even cavities or layered structures. To understand the significance of 32 Atlas, one must consider the two interstellar objects that preceded it. In 2017, Oumuamua became the first confirmed interstellar visitor to our solar system. Its elongated, cigar-like shape, lack of a cometary tail, and unexplained acceleration as it passed the sun baffled scientists. Harvard astrophysicist Avi Loeb proposed that Oumuamua might be artificial, a probe or relic from an advanced civilization. Though his hypothesis was controversial, it ignited a debate about the possibility of extraterrestrial technology. In 2019, a second interstellar object, 2I/Borisov, entered the solar system. Unlike Oumuamua, Borisov resembled a traditional comet, with a visible tail and volatile behavior. Yet its speed and composition set it apart from solar system comets, hinting at its interstellar origins. These two objects, though distinct, shared one unsettling trait. They defied easy categorization. Now, 32 Atlas combined the anomalous brightness of Oumuamua with the precise trajectory of Borisov, amplifying the mystery. Before 2017, no interstellar objects had been detected. Now, within a decade, 3 had appeared, each stranger than the last. This sudden influx prompted speculation. Was this a coincidence, or part of a larger pattern? The timing of these arrivals coincided with humanity's growing technological sophistication, particularly the deployment of advanced observatories like JWST. Some scientists began to wonder if these objects were not random wanderers but deliberate visitors, timed to coincide with our ability to detect them. As JWST continued its observations, the data grew increasingly unsettling. Spectral analysis revealed absorption lines suggestive of advanced carbon structures, materials more akin to engineered composites than natural geology. The object's reflectivity, far higher than that of typical asteroids, pointed to a metallic or polished surface. Its spin exhibited a symmetry that suggested design, with one side absorbing more heat than the other, a feature rarely seen in natural objects. Most alarming was the detection of slight, non-gravitational acceleration. Unlike Oumuamua, where such acceleration was debated, 3-2 Atlas's deviations were measurable and consistent, defying explanations like solar radiation pressure or cometary outgassing. These findings echoed Loeb's earlier warnings about Oumuamua. He urged scientists to consider the possibility of artificiality, arguing that non-gravitational acceleration could indicate navigation rather than drift. If 3-2 Atlas was navigating, it implied intent, a purpose that transcended mere chance. The implications were staggering. This could be a probe, a relic, or a messenger from a civilization far older and more advanced than our own. At NASA's Goddard Space Flight Center, researchers grappled with the data. The object's thermal signature, spin, and electromagnetic readings pointed to a level of complexity inconsistent with natural phenomena. Internal memos began circulating, cautiously raising the possibility that 3-2 Atlas was not a rock but a constructed object. The term artificial was rarely spoken aloud, but it hung heavy in the air. If this was indeed a product of intelligent design, it raised profound questions. Who built it? Why was it here? And what did it want? As the scientific community grappled with these questions, a subtle shift occurred. Initial excitement gave way to a cautious silence. NASA, the European Space Agency (ESA), and India's ISRO, which had initially shared trajectory data and light curves, began to restrict access. Mission pages went offline, observational timelines vanished, and requests for JWST data were denied, citing internal review. Freedom of Information Act, FOIA, requests returned heavily redacted documents, fueling speculation among journalists and independent researchers. This sudden opacity suggested that something extraordinary had been uncovered, something agencies were not yet ready to share. Whispers from within observatories hinted at reassignments of key personnel and restricted access to telescope feeds. The public, initially captivated by the discovery, now faced a wall of silence. Analysts speculated that the data had crossed a threshold, moving beyond the realm of science into matters of national security or global stability. In space, control is often maintained through silence, and 3-2 Atlas was no longer just a scientific curiosity, it was a potential paradigm shift. The discovery of 3-2 Atlas forced a reevaluation of humanity's place in the cosmos. For centuries, we assumed the universe was indifferent, a vast emptiness punctuated by lifeless stars and planets. The arrival of 3 interstellar objects in less than a decade challenged that assumption. If 3-2 Atlas was artificial, it implied a civilization capable of constructing objects that could survive millennia in deep space, navigating with precision and purpose. Even if it was natural, its properties suggested a phenomenon so advanced it mimicked design, exposing the limits of our understanding. The timing of its arrival was particularly striking. Humanity's ability to detect such objects had only recently reached the necessary sophistication, with systems like Atlas and observatories like JWST. Was it a coincidence that these visitors appeared just as we gained the tools to see them? Or had they been waiting, watching, until we were ready to notice? Avi Loeb, undeterred by skepticism, argued that 3-2 Atlas could be humanity's second chance to decipher a cosmic message. If Oumuamua was a missed opportunity, this object offered a new window into the unknown. Its properties, speed, reflectivity, trajectory, and acceleration, pointed to intentionality, a hallmark of engineering. As JWST continued to monitor its path, scientists braced for answers that might redefine our understanding of the universe. As 3-2 Atlas continued its silent glide through the solar system, a new realization dawned. This was not just a data point but an inflection point, a moment that could alter humanity's trajectory. If artificial, it suggested we were not alone, that we had been watched for eons by a civilization whose technology dwarfed our own. If natural, it revealed a universe far stranger and more complex than we had imagined. The James Webb Space Telescope, humanity's most advanced eye into the cosmos, had held up a mirror to our ignorance. What it reflected was not just an object but a question. Are we ready for what comes next? As the object moved closer to the heart of the solar system, its trajectory unwavering, the scientific community and the world at large awaited answers. But one thing was certain. The void was no longer silent. And whatever 3-2 Atlas was, it had our attention and perhaps we had its.